Hi, this is Wendy Lightheart, and for this lesson we're going to use those skills we've been learning on how to multiply polynomials to find some special products. So the first special product we're going to take a look at is the sum and difference of two terms. So notice that what we have here is a plus b times a minus b. So the a plus b is a sum and the a minus b is a difference. And notice that we have the same two terms, a and b, in both of those cases. So this formula tells us that the product of the sum and the difference of the same two terms is the square of the first minus the square of the second. So here's our first example. We need to multiply x minus 5 times x plus 5. Since this is the product of a sum and a difference, we can use the rule. So notice that the rule says we have a plus b times a minus b, but remember the order doesn't really matter when you're multiplying, so it's okay if we have a difference first followed by a sum. It's still the product of a sum and a difference. So I'm going to reorder the x plus 5 and x minus 5 just so we can see how it follows the formula. So notice that our a is x, because that's the first term in both sets of parentheses, and the b is 5, since b is the second term in both sets of parentheses. So if we go to the other side of the formula, we replace all the a's with x and all the b's with 5. So we have x squared as our first term, minus 5 squared as the second term. So we end up with x squared minus 25 when we simplify. So one thing to note is whenever you're multiplying a sum and a difference of the same two terms, you'll always end up with only two terms. Now the next product is called the square of a binomial sum. So notice that we have a binomial inside the parentheses, and because there's a plus sign between the two terms, that would be called a binomial sum. And we're squaring the binomial sum with that exponent of 2. So this formula tells us that the square of a binomial sum is the first term squared plus twice the product of the two terms, a and b, plus the last term squared. So here is an example of the square of a binomial sum. Because notice we do have a binomial, x plus 7, and it is a plus, so that means it is a sum. So we can use that rule that we just talked about. So we need to notice first that the a is going to be x and the b is going to be 7. So we're going to use the formula and replace all of the a's with x's and all of the b's with 7's. So we have a squared becomes x squared. Then we have plus 2 times a, which is x, times b, which is 7. And then our last term would be plus 7 squared. So notice we just replaced all the a's with x's and all the b's with 7's in our formula. And then our next step is to simplify. So we get x squared, and then for the middle term we have 2 times 7 is 14 to get our coefficient. So we get 14x as the middle term, and then we end with plus 49, since 7 squared is 49. Now, I don't know about you, but for me, the less formulas I have to memorize, the better. So the nice thing about squaring a binomial sum is that you can also use FOIL instead of the formula, and that way you don't have to do any memorization of a formula. And the reason for this is that when you're squaring an expression, remember that that just means that you're multiplying it times itself. So if you first rewrite the square of the binomial sum as the product of that binomial times itself, so a plus b times a plus b again, then you can use FOIL to multiply it out. So for this example, this is going to show you where the formula comes from by foiling this out. So the first term will be a times a, which would give us a squared. The outside term would be a times b on the outsides, so that would give us positive ab. Then on the inside we have positive b times positive a, so that would give us a positive ab for the third term. And then our last term is positive b times positive b, which is plus b squared. And then when we combine like terms, we end up with the formula that we saw before. So let's see how we can apply that to the same example that we looked at earlier that we used the formula for. So we have x plus 7 squared, but remember that when we're squaring something, that means we're just multiplying it times itself. So if we use that definition, we can rewrite x plus 7 squared as x plus 7 times itself. That's how we start off by using FOIL in this situation. So now if we FOIL this out, we're going to have x times x for the first term, so that's x squared. Then on the outside we have x times positive 7, which is positive 7x for the second term. Then we have the inside terms multiplied together, which would be positive 7 times x, which gives us plus 7x. And then our last term of FOIL would be 7 times 7, which would be 49. Then of course we combine like terms, and notice we get the same answer as we did before using the formula. But we didn't have to memorize a formula, we just had to remember that when you square a binomial, you're simply multiplying it times itself, and then we use FOIL. Our last special product we're going to look at is the square of a binomial difference. So this looks very similar to the square of a binomial sum, except for we have subtraction in our binomial that's being squared. And you'll notice on the other side the formula only differs by one sign. So everything's the same except for the second term is negative instead of positive, like it was with the square of the binomial sum. So this says the square of a binomial difference is the first term squared minus twice the product of the terms plus the last term squared. So let's see how we can use that rule to find 3x minus 5, which is a binomial difference, squared. Since this is the square of a binomial difference, we can use the rule. So here's the rule again. So if you have this rule memorized, you just have to determine what the a is and what the b is, and then plug them into the formula. So our a is 3x, since that's the first term of that binomial, and our b is 5. So we need to square the 3x first, then we have minus 2 times the 3x again, times the 5, plus the b squared, which would be 5 squared. So that's just replacing all the a's with 3x and all the b's with 5 in our formula. Now we simplify, so we square the 3x, and remember that means you have to square the 3 and the x. So we get 9 for the 3 squared and x squared for the x squared. Then we have minus 2 times 3x times 5. We have to multiply those three coefficients together, so 2 times 3 times 5 gives us 30. And then we have the x there. And then our last term is the 5 squared, which of course is 25. So just like the square of a binomial sum, if we have the square of a binomial difference, we can also use FOIL in that scenario. So you don't have to memorize the previous formula we just looked at either. If you prefer, you can use FOIL instead. Because remember, if you have a minus b squared, so a binomial difference being squared, that just means that you're taking that binomial difference and multiplying it times itself. So for this example, that means 3x minus 5 squared, we would start by rewriting that as 3x minus 5 times 3x minus 5. So now we can FOIL. So when we FOIL, we have our first term times our first term would be 3x times 3x, which is 9x squared. Then on the outside we have 3x times negative 5, so that would be a negative 15x. Then on the inside we'd have negative 5 times positive 3x, would give us another negative 15x. And then our last term would be negative 5 times negative 5, which would be 25, a positive 25. Then we combine like terms, and notice that we get the same answer as we did when we used the formula. So it'll be up to you whether you want to use the formula or FOIL for these examples. You will have to memorize the formulas if you prefer to use the formulas, but either way you'll get the same answer. And that's it for this lesson. See you later.